the polyphosphorine as the adjuvant for the efficient in-over vaccination against fowl adenovirus 8B in chicken. Suleman, please.
Exactly, I was finished before that. Bismillahirrahmanirrahim. Thank you very much for the organizer of IPEX to allow me to present my work here. My name is Suleman, and I was working as a research officer in video intervac. To begin my presentation, I would like to show you a 3D model for the adenovirus. The second picture you see over here is an in-over vaccination strategy, and the third is a pretty picture of a chicken. So my major objective was to look at two different types of adjuvants and look for the protection by in-over vaccination along with inactivated adenovirus. A very brief outline. There are 5 points. I will start with the introduction. I will go with the in-over vaccination, then the introduction for the adjuvants, and 12 serotypes and 5 species. And the one which we are looking for is basically the IPEX, which calls the inclusion body hepatitis. And the subspecies that we are looking for, that we are working on, is called as the adenovirus type 8B. And why we selected this particular serotype, I will let you know in the next slide. The particular image that you see over here, we started by isolating this particular isolate from the local forms of the promise where I was working in Canada. And here you can see a cell line, which is the control, and the CPE of adenovirus 48 hours post-infection. We performed the electron microscopy of the cells. You can see that the dark spots over here is the multiplication of the virus inside the cells. And then we performed the electron micrography of that particular isolate that we have over there. We identified our particular virus by doing the genotyping as well as by restriction analysis. And we named it as adenovirus inclusion body hepatitis Saskatchewan L1. If you look at the clinical picture, you guys are pretty much clear how this particular virus works. It is basically transmitted horizontally as well as vertically. So the control is pretty much difficult, so we have to build a vaccine that can control this particular infection coming from the breeder flock. If you look at the onset, it is sudden onset, and basically there is acute mortality. And that mortality can be seen pretty quickly. The birds will be down. They have pale comb. If you look at the histopathology, you will see the pale liver and mottled liver, which you can see right over here. This side is the normal side, and the one over here, mottled, is basically the one which is having inclusion body hepatitis. If you look at the histopathology slide, the orthognomonic lesion that you will find are the basophilic intranuclear inclusion bodies. If I can point the dark spots over here, where the virus multiplies inside the nucleus and generates the inclusion bodies. And it definitely leads to severe economic losses too. Starting up the point of why we look up the in-over vaccination, why not perform the vaccination in the day-old chick or a week-old chick? You can see an image of ovum right over here and the in-over vaccination strategy. The importance of using this particular technique is that when we perform the in-over vaccination at day 18 of the incubation, it can basically lead to increased activation of CD4 and CD8 cells in the spleen of the chicken. And that particular activation of all these, you see over here, CD4 and CD8 lymphocytes is basically going to protect the chicken in the early age, the first few weeks of its when it's born. And that particular increased response is not only related to the antigen that we put in, but we also protect to the other antigens that will be exposed later on. Another very nice finding that is reported that there is a lot of immunoglobulin A produced at the mucosal sites. And that could be respiratory mucosa, intestinal mucosa, and that can protect the particular bird in the early phase of life against various pathogens. Very briefly, 2 slides for the 2 different adjuvants that we selected to use. They were recently commercialized, so we picked them. The first one has a longer name, but we call it as a polyphosphorines. This particular adjuvant has the capacity of being biodegradable, water-soluble, so it can easily be used for in-over vaccination. It is a very potent enhancer of T1 and T2 type of immunity. It is a very potent activator of interferon gamma, IL-6, IL-12. And along with that, the major beauty of this particular adjuvant is that it can recruit a lot of immune cells, leading from neutrophils, macrophages, dendritic cells, all those cells which are involved in presenting the antigen, capturing of the antigen, and that can lead to enhanced immune responses. And it has already been reported to be a safe adjuvant in various experimental vaccines for different animals. Now jumping on to the next adjuvant that we selected was called as avian beta defenses. There are multiple types, but we selected one particular type, which is type 2. And these are the antimicrobial peptides, which are linked to attracting a lot of dendritic cells. If you look at the acceleration, that it will not only attract the immature dendritic cell to the infection site, or it will also activate their maturation very quickly. Another good point for that is the strong inducer of various cytokines, which includes interferon gammas, IL-12s, and it can also attract a lot of interleukins at that point. And when it attracts a lot of macrophages and dendritic cells over there, it can lead to increased phagocytosis. When the cells are mature, they are ready to capture the antigens or the pathogens and produce the immune responses. And then at the end, the whole combination of this particular adjuvant is that it can significantly enhance the innate immune responses at their site. To begin with, a very simplified picture of, without going into the details, how we did the vaccine trial. We performed 3 different vaccine trials. We started with inactivating the adenovirus. We added the different combination of adjuvants. I won't tell you how much or how many micrograms, but it's probably already there for you to look at. And we did the intra-amniotic vaccination at day 18 embryos. And we generated a timeline for sampling when the chicks are born. So we sampled the chicks at different ages. We selected to get the serum samples, and we did some organ sampling to get hold of the cytokines as well as the genes that we want to look at. A very simplified slides for 3 vaccination trials in a single slide. The vaccine trial 1 basically shows that we have a formulation of, if you see over here, I will simplify it for you. If you look at the green line at the top, which could be right over there, you can see. So the green line at the top, you can see that initially the immune responses pick up slowly, but at day 14, we have a very strong immune responses, which is the anti-adenovirus titer that we found. We repeated the similar vaccine trial with a similar number of animals in the same composition, but we wanted to see if the immunity against that particular adenovirus subtype can be prolonged or not. So we saw that the immunity that we got at day 14, like 2 weeks, we can basically achieve the same results, even higher titers at day 28 or even beyond that. And we did the third trial, which was basically aimed to reduce the dose, that if we can produce half of the antigen, keeping the same amount of adjuvants, can we achieve the same titer and same protection? And we found that if you see the green line on the top, which is polyphosphazines plus virus, always on the top you can see the green line, which is having a particular composition that generated a very high immune responses over there. Looking at the gene responses, like if you want to see that if there is some innate immune responses are there, a little complex image, but I can put the arrows on the top. You can basically see at day 17, we have a very high peak of interferon gammas, along with the polyphosphazines in the beginning. The second arrow, you can see there is interferon gamma production at day 17, which is pretty significant as compared to the early time points. And there is a lot of IL-12, which is there, which is again important for controlling the infection. If you look at the IL-6 production, we also have, if you see the third arrow over here, at day 17 of infection, it slowly builds, but then again, there is more as compared to the kill virus or the previous controls that we did over there. In most of the vaccination trials, we would like to immediately identify if there are any cellular responses. Even if we have a lot of antibodies produced in the serum of the animal, we will like to see if there are proliferation of the cells or the immune cells are proliferating or not. So we performed the effects analysis for that particular sets of samples, and we identified that the kill virus with the polyphosphazine was capable of proliferating B cells and monocytes way more than the controls. Lastly, we performed a challenge model. We performed the vaccination in our group, and then we added the 10 to the 60 CID50 of the challenge of the virus at day 15, and we saw another peak of immune response that goes high, indicating that there is more protection and antibody production as compared to the other conditions. And the only clinical signs or mortality we saw was in the PPS control. The rest of the birds were protected completely without any clinical signs, indicating that there is a lot of protection that we saw is present there. To conclude my presentation, I would like to say that this particular model produced higher antibodies. It produced higher levels of interferon gammas, IL-12, IL-6, and we have a lot of multiplication of the immune cells by proliferation, which are important. And at the end, we can say that they have better innate and humoral responses and cellular responses. What is there for the industry is that we would like to introduce that particular adjuvants and vaccine for the commercial level trials in the industry, so that we can introduce it in the industry to test this vaccine on the commercial levels. And also we would like to combine this particular vaccine with other Innova vaccination strategies by combining it with the vaccine for the Marek's disease or other diseases which are transmitted vertically in the birds. This is the link of the paper where it has been published. And that's pretty much it. I would like to acknowledge the group members, particularly Dr. Tipu and Sir Tiku and other people which were working with me at the video interact right over here on the top, the vet college on the bottom. This is a group of scientists working on it, and a little picture of me with the colleagues. And I would like to mention that this particular combination of results with these adjuvants, we have published it for another vaccine. And that particular vaccine was awarded the Best Veterinary Vaccine Award in 2019 at Washington. And lastly, these are the funders or the agencies that were supporting us for this particular work in Canada. Thank you very much for your attention.